Alright, hey everybody, we are going to talk about how to solve quadratic functions by factoring. So all that practice we did with factoring comes into play here. I know that we briefly mentioned it in the previous videos when we talked about the zeros and the roots of a quadratic. So what we're going to do is we're actually going to do a factoring problem. And the reason why we solve by factoring is we want to know where the quadratic touches the x-axis, and that would be our zeros or our roots. And in order to find those, we need to find the factors first. So here's an example of a solving by factoring. I have an equation, and it is quadratic because the x squared is the highest exponent, and it has a degree of 2. Now I notice that this equation is currently not in standard form. Standard form is ax squared plus bx plus c. In order to get it to the correct position and the correct form, we must subtract 6 from both sides, and therefore we will have 2x squared plus 4x minus 6. Now notice you do not subtract the 6 from either the 4x or the 2x squared because they are not like terms. 6 does not have an x on it, therefore we cannot combine it with 4x. And then 6 minus 6 results in a 0. So what you're looking for here is you always want to make sure the equation is set equal to 0. So we are going to factor this side of the equation right now. First off, I notice that there is a greatest common factor. Remember that we always check for GCF before we do anything else when we're factoring. So I notice that 2 will go into 2x squared, 4x, and negative 6. So I'll have 2 and in parentheses x squared plus 2x minus 3. Don't forget your equals 0 here. We're going to bring this equals 0 with us down the entire way. Alright, so now we need to factor the inside of the parentheses. So what two numbers multiply to negative 3 that will add to positive 2? And that will be negative 1 and positive 3. So here's the factored form of the quadratic 2x squared plus 4x minus 6. So what does this do for us? What we are going to do is we are going to take each factor and set it equal to 0. Well, let's see. If I take x plus 3 and set it equal to 0, for what x value will this result in a 0? So subtracting 3 from both sides, my first answer is x equals negative 3. Now doing the same for x minus 1. X minus 1 equals 0. Adding 1 to both sides, I get the root or the 0 as x equals 1. So my two answers here are x equals 1 and x equals negative 3. So now we know that we have two answers, and the reason I know that I should have exactly two answers is that the highest exponent, or the degree, was 2. So I should have two answers. Sometimes we have where we factor out an x because it's x cubed, x squared, and an x. So in those cases you would need to have 3 answers, meaning that you set whatever's in front of the parentheses equal to 0 as well. However, in our case, there's no variable here, so 2 equals 0 doesn't make any sense. We know that the two answers for this problem are 1 and negative 3. Alright, so now let's begin with this one. First step is to make sure it's set equal to 0. That has already been done for us. So now we need to simply factor the quadratic. So 2 parentheses, what two numbers multiply to 49 but will add to 17? That is positive 7 and positive 7, because 7 times 7 is 49, 7 plus 7 is 14. So I will set each one equal to 0 and solve for x. So subtracting 7 gives me x equals negative 7. Subtracting 7 gives me x equals negative 7. So the two answers I have are negative 7 and negative 7. And you may say, well, technically that's the same answer, and it is. But if we were to have the graph of the parabola, let's say that this point is negative 7. The way that your quadratic would look is that it would come down, it would touch negative 7, and come right back up. Usually when we think of parabolas, we think of them as crossing the x-axis twice. However, that's not necessarily the case. Okay, it can, if the answer is the same for both, come down, touch it, and then come right back up without actually crossing through into the negative area. All right, next one. We know that this needs to be set equal to 0. Because it already is, let's just factor the quadratic. All right, so x squared minus 10x plus 25. What two numbers multiply to 25, but will add to negative 10? And I see negative 5 and negative 5. So x minus 5 equals 0. Set each factor equal to 0. Solve for x. So again, I get the same answer twice, but I need to know that the answer is twice. So the solution here is 5. The root is 5. The 0 is 5. The x-intercept is 5 and 5. So remember that we can use any of those four names from the previous video to ask you these questions. Alright, now at this one, it is set equal to 0. Notice there's only two terms. Remember, you always check for a GCF. I see that 3 will go into 3x squared and negative 108. So I'm going to pull out a 3. Now with this two terms, I'm going to check and see, can I do difference of squares? And I can, because x squared is a perfect square and 36 is a perfect square. So I get x plus 6 x minus 6 equals 0. So set each factor, x plus 6 and x minus 6 equal to 0, and solve for x. So we have x equals negative 6 and positive 6. Another way to write that would be plus or minus 6. So I would accept these right here or this one by itself. So either these two or this one. You choose. Okay? Alright, so what does that look like to us? Okay? So in the graph, here's the graph of 3x squared minus 108. Okay? When I graph this, when I set y equal to 0, because at the x-axis y does equal 0, when I do that, I'm going to get the solutions, or the zeros, or the roots, or the x-intercepts, yada, yada, yada. There's a lot of them there. So, if you'll notice, it crosses at negative 6 and positive 6, and those were the roots that we found to have in the previous problem. Alright, so the problem that you see here is the last problem that we will do today. First off, I need to make sure it's set equal to 0, and it is. Now what I need to do is factor the left-hand side. I notice that there is a greatest common factor. Okay, so what you can do is you can look at each one and see what number goes into 4, 36, and 80 evenly. And I also notice that I have an x to the 3, x to the second, and x to the 1. So I can pull out an x, and 4 goes evenly into 4, 36, and 80. So I'll be left with x squared minus 9x plus 20. Okay, so then we will factor what's inside the parentheses, leaving the 4x out front. The two numbers that multiply to positive 20 that add to negative 9 are negative 4 and negative 5. Now, if you will, take a minute, look at the degree. The highest exponent is 3, which means I need 3 answers. Those 3 answers are going to come from these 3 factors. You're going to set 4x equal to 0, you're going to set x minus 4 equal to 0, and you're going to set x minus 5 equal to 0, and solve for each one. So in the first case, you would divide by 4, and you get x equals 0. That's my first solution. Adding 4 to solve for x gives me x equals 4 for my second solution. And adding 5 to solve for x gives me x equals 5 as my solution. So my x-intercepts are 0, 4, and 5. Alright, well that's it for today in solving by factoring. I will see you guys later.